Howdy folks, James Finnerty here with Rewind Electric, and we're gonna crack back into this Deluxe Electric Mistress today. I've been promising to do a calibration video on it, and that's exactly what I'm gonna do. Now, I've not actually tested or changed out the internal electrolytics on this yet. I'm still waiting on them. So we're gonna just sort of consider this a roughing it in or a test run through perhaps, because it's possible that when those get changed out, if they get changed out, that it will need to be recalibrated. Now if it turns out that none of the caps in here need changing, then it'll be just fine. Calibration will still be valid, and really at the end of the day, it's a guitar pedal, and how it sounds is what matters. Now, that doesn't necessarily mean you can just be like, it sounds great to me, I'm going to leave it alone, because you don't really know if it's running correctly now. But if you test it and you rough it in and it seems good and it sounds good and you want to dial it a little bit out of spec, that's another story. You could do that too. So, I'm going to fire up the Princeton reverb here. I did get some of these really cool blue zip ties that have a coated iron core and plastic coated paper, so they are a little bit safer, even though they're still appropriate for this. It's funny, this looks like such a disaster here, but this is actually not a mod. This is, well, I mean it is. It's a factory mod though. Little loose bit of solder there. So what they did was cut that trace and then put this capacitor resistor network over there. So it looks to me like they're probably filtering out some frequencies with that. Could be an attempt to eliminate noise or something. So, all right, let's fire this up. I suppose we'll do it at 117 volts because that's what I'll likely run it at. Okay. Now, for this one, we're going to need a signal generator, which I have here. I need an oscilloscope, which I have up there. You guys can't see the scope. I guess I could move the camera up if something particularly interesting happens. So, okay, let's see here. Set the rate and color control. Oh, you know what else I'm gonna need is a tweaker. Yeah, gonna need to get one. Got a little bag of tweakers and terminators and adapters and parts here. One of those should be good. Let's see. I think this is what I'm looking for. Is this it? Might be a little small. See if I have a size up. Maybe not. I also have this. I have a lot. Let's just start with those and see if they work. If we need more, we've got them. All right, so this is live. Calibration instructions say set the rate and color to minimum. Set the switch to the filter matrix position and set the range to maximum. VCO input voltage at pin 2 of the LM311 is now at its highest peak. Set the clock trim for approximately 35 kilohertz. Square wave at pin 1 or 5 of the 4013, test point 1. Okay, the 4013 is here, so 1 or 5 would be, let's take this off. This thing's kind of twisted. Let's clip it to ground. All right, 1 or 5 would be one of these. You guys, 1, 2, 3, 4, 5, one of those two. So I'm gonna just put the probe there. Set the clock. Let's see what it reads on the scope now. Try and do a. Okay. So the scope picked that up right away, no problem, and it's telling me 88.6 kilohertz. What am I looking for? Ooh, 35 kilohertz. Wow, okay. 28.6 milliseconds period. What's the period on this? Nothing like that. 11.4. All right, so yeah, we're way off. Where is the clock? Clock is this one. Okay, so go back to pin 1, and we want to twist that until we get, yeah, this is 35 kilohertz. Okay. I really want to show you guys that, but I don't know that I have a place I can clip this on to free up a hand. 1 or 5, let's see. 1, 2, 3, 4, 5. Yeah, there's nowhere that I can really. Okay, let me try something. See, I want to show you my scope here. In fact, I could turn the light down and make it a better view. Let's try something. Okay, I think that'll work. All right. Yeah. Okay. Now, is that good? I think that's pretty good. Maybe I should zoom. Can I? Yeah, let's go like this. That's pretty good. That might work well. Should have done this with 2 cameras or 3. Okay. All right, so see where it says frequency and there's nothing there? Well, now let me put this probe onto pin 1 of that 4013. And there's a square wave, you'll see. And in here it says right there, we're looking at the frequency, 64.4. And the period here is about 15.5. Now, what the calibration instructions from Electro-Harmonix are calling for is not that. They want to see 35 kilohertz or a period of 28.6. So we're going to twist the adjustment for the clock until we get that 28.6 period. Okay, we're going the wrong way. Wait, no, that's it. But you see, as I adjust that, it gets faster and slower. 28.6. Oh, we're very close. A little too far. And we're looking at 35 kilohertz is what we want. We're very close. Oh, we're so very close. Okay. Oh, overshot it. You know what? I just want to twist that pot around a little bit, try and clean it. 35 kilohertz. I mean, it doesn't have to be exact, but I want to give it my best. That's pretty dang close, right? Okay. I don't think we're getting close to that. 28.54 and 35.09 kilohertz. That's, we call that dead on. Now bias, keep the rate and color controls at minimum, range at maximum, mode switch at filter matrix. All right, so we've already there. Connect a 200 hertz sine wave to the input and adjust the bias trim for maximum input signal amplitude without clipping at the wiper of the balance trim. The input amplitude should now be greater than 1.6 volts peak to peak. Okay, I'm just following the instructions here from Electro-Harmonix. So input, now I will have to, the signal generator I'm using at the moment is analog, so I'm gonna have to clip onto here and then actually measure it on the scope to get that. What do they want? 200 kilohertz? No, 200 hertz. Yeah. Because I can't just punch in 200. Not on this one. Okay, so let's run a auto setup here because it's, you know, now we're putting out a totally different signal. It's jumping all over the place. It doesn't know what it wants. All right, that's 3 kilohertz. We want 200 hertz. So like way less than that. I think we're gonna be probably in this range somewhere. It's pretty close. Let's dial it in. As I adjust the frequency on this, I'm moving that around. And I'm looking for 200 on that frequency right there. We're pretty close to it. Yeah. Again, this isn't exact, but I can get it pretty close because I've got a vernier controller on here, which is just a fine adjustment. Okay, yeah, 200.17, we'll call that good. And we're looking at, okay, connect a 200 hertz sine wave to the input and adjust the bias trim for maximum input signal amplitude without clipping. Okay, so at test point 2, which is the wiper, yeah, all right. I think I actually can clip this. There is a little leg of a component connected there that I can just clip onto. Okay. When it beeps, I'm just hitting auto setup, at least for the moment. Okay. Having a little trouble tracking that. So let's see, now I'm doing maximum signal. So how much can I crank that without it clipping? About that much. Now you see it starts to clip on the bottom first. I might be able to get that to stand still better if I have a clock signal out from my function generator that I might be able to connect to another input on the scope here. Let's try. And then trigger. Yeah, it's funny how it's jumping around there. Not quite sure why that is. It's the scope though. It's just not locking on for some reason. Maybe I'm not sending out the right kind of sync, or I may not have this set to receive sync. See what I did here. Let me show you guys what I'm talking about. Over on the signal generator here, this WaveTech signal generator, this is the audio output going into the Deluxe Electric Mistress, but then it also has this here is just a clock sync output from it, and I connected it to that second input. And I thought that that would automatically set itself up, but it might actually, this scope might prefer that I connect that to a clock input on the back rather than just another input on the front, or at least program it to receive it from the front, but I'm not going to get into that right now. I mean, it's good enough that I can see where it's clipping. We can all see that, right? See, like now it's clipping on both the top and the bottom. Now it's clipping on the bottom. Now it's not clipping at all. So what the bias is going to do is shift that signal up and down within this bandwidth. And I want to do that so that it clips at the bottom and the top at the same time. And that way we're getting the most signal out of it. So what am I adjusting? The gain, right? Balance trim to adjust the bias trim. Where's the bias? Okay, bias is over here. Okay, so as I adjust that bias, it should move that signal up and down, changing which side clips first. Yeah, now we're clipping on the top first. Now we're clipping on the bottom first. So I want to get kind of the same amount of clipping on both. Probably something like that. Probably like that. And then as I back this down, the gain on, or you know, the output on the signal generator. Okay, so now it's not clipping at either end, and if I just nudge it a hair, it should clip at both. Yeah, so that's it. Okay, so I think that's about maximum bandwidth. And now, what does this say we're getting? Peak to peak, 27.8 volts. That doesn't seem right. Let's see. Greater than 1.6 volts. What is my probe set to? The probe has two settings on it itself, so I just changed the probe setting. And now it says 1.6 volts. It's also got a messy view again. But okay, so if I just change the probe setting, .3 volts peak to peak. That's definitely greater than 1.6. Almost feels too good to be true. Am I clipping still? Maybe I am. Let's back it off a hair. 3 volts. It's just picking up a harmonic of that wave. That's why it's having trouble syncing. 3.02 volts peak to peak. Well, I mean, that's certainly like more than 1.6, so yay, I've got a lot of headroom. Okay. Gain and balance adjustment. Keep the rate and color controls at minimum and range at maximum. Is that where we are? Rate and color at minimum, range at maximum. Yes. And mode switch at filter matrix. No sweep. All right, connect the 200 hertz sine wave to the input and adjust its level to achieve an amplitude of 1 volt peak to peak at pin 6. Oh boy. of the 741. I remember there's something in this instruction manual about that. Is there even a 741 in this? All right. Set the gain trim to 1 volt peak to peak at the wiper. Right. Set it at 1 volt. Okay. I think it wants. Let's keep the rate and color at minimum. And okay, we're all there. 200 input. Adjust its level to achieve an amplitude of 1 volt peak to peak at pin 6 of the 4 6. So 1, 2, 3, 4, 5, 6. I think it wants this IC. That's telling me I have 2.3 volts. Wow. Well, I landed on that 1 volt peak to peak. I just nailed it, didn't I? Let me come in here and zoom a little bit better. Which is going to require an adjustment of the camera. Okay. This is where we're looking at the peak to peak measurement. All right. I mean, that's a dead on perfect one. Well, it's fluctuating here. Okay, we'll call it 1. All right. Now, set the gain to 1 volt at the wiper of the balance trim. Set the gain, which is up here, to 1 volt at the wiper of the balance trim. .4 volts. So you want to set that at 1. Try to bring that back on the screen. Oh boy, it's very sensitive. Okay, that's as close as I've gotten it, and I'm going to leave it there. Set it to 1 volt peak to peak at the balance trim pot wiper, which I am measuring it. Disconnect the input and set the balance trim for minimum clock noise. Repeat gain and balance adjustment procedures until no more are necessary. Okay. Disconnect the input. Now it wants me to plug it into an amp. Oh, I guess you could do it on a scope, minimum noise. Maybe we should try it on a scope. Okay, let's look at it on the scope and see what kind of noise there is. Can we do that? output. I think it's just going to give me a mess because the signal is so low. It's set at 10x. I want to go to 1x. Now I'm not running any signal into it either. So that's going to be interesting. Yeah, it's not finding much. That's disconnected. That's just the probe itself being. That's disconnected from ground too. See, I could stick this on ground here. I can calibrate the probe a little bit to get rid of some of that on this scope. Let's try that. Okay. So adjust. Disconnected was at balance trim for minimum noise. Okay, here's the balance. There's a lot of noise. Oh, okay, yeah. You see, if I'm turning it counterclockwise, now it's going down and come back. As I turn it clockwise, it minimizes and then comes back. So I'm looking for minimum. It's probably about there. Interesting. I did this with an amp before and I couldn't hear it. So this is definitely the way to go. These pots are way too sensitive though. It needs a much finer adjustment. That's it. Right about there. I don't think I can get it less than that. You want to look at it this way? I'll do it again. So this is just with the 10x setting on the probe. And you can see the noise come and back the other way. And then right about right there. I'm going to zoom in to just get it as good as I can. Back to the 1x setting on the probe. Okay, and I think that's it. All right, cool. Repeat the gain and balance adjustment procedure until no more changes are necessary. Okay. So back to the 200 hertz sine wave for the input. All right. For that 1 volt peak to peak at pin, what was it, 6? Yeah, pin 6. Okay. I'm gonna restart this. Oh. My scope is froze up. What did I do? Interesting. Well, I'm gonna have to shut it down. I don't think it'll hurt anything. it should go off. There we go. Okay. So that was weird. I don't know what to say there. My scope kind of froze up on me. I don't know if I bumped something and locked it when I was calibrating that probe. That is possible. Let's bring it back up. I mean, it was still working, just the front panel controls were, I was locked out. Now it's still thinking about it. Okay. Try to get on. Oh, I should have put the probe on there first. Okay. Yeah, it's telling me I have 8.8 volts peak to peak because I'm on the 1x setting of the probe. I think it wants me to be on the 10. It's going to probably tell me I have 8.8. A little higher than that. Okay. So I'm looking for 1 volt peak to peak. Adjust this. There we go, 1.02. I don't think I'm gonna get closer than that with this signal generator. And then move over to the wiper, right? And adjust the balance. Oh wait, I set the gain. Okay, so move over to the wiper and set the gain for 1. Oh, that's so close. I'm not gonna get any better than that. I'll try. Where were we on this one? 1.02. I'm just trying to match it. 1.02. 1.01. I'll probably never get that close again. Okay. 1.03, 1.02. That's it. Okay. Whew. All right. And now disconnect the signal from the input and monitor the output and adjust the noise, and I'll be good after this because that was already like so dead close. I'm just kind of like I'm adjusting inaudible levels of stuff here at this point. It's not much point in going beyond that. Okay. Let's see. All right, there's my noise. I'm gonna go to the 10x setting just to amplify it a little bit. And I'm adjusting the balance pot, which is that one with the wiper we've been measuring. Okay, right here. And increasing, turn it back clockwise, increasing again. That's it there. Yeah, I think we're probably good. Let's continue on. Bias adjustment. Repeat the bias adjustment in various settings of range. Oh. Okay. Bias adjustment. Put our 200 hertz sine wave back in. And adjust the bias for maximum input signal with the balance. Okay, and the range is the middle pot, right? Yeah. Okay. Okay, so there's, whoa. There's the probe on the wiper of that pot. It won't stay on this little lead now. Okay. Let's bring that up on the scope. Okay, now are we still at maximum amplitude for not clipping? Or at least we're clipping evenly on both sides. We're biased. And, oh, we're going way above. Okay. Let's bring that back in range. Okay, so we're clipping on the top and not the bottom. Alright. Well, it's close, but yes. And I haven't even changed the range pot yet, so bias over here. Okay, that's probably even. Now, if we change the range, what happens? There's minimum range. We could take it down. And if we go to maximum range, it's clipping at the floor. Let's put it in the middle. A little bit of clipping on top at max, a little bit more clipping on the bottom at minimum, and in the middle it's even. I think that's as much as we could ask for. I mean, just turn the signal down, it doesn't clip anywhere, but that's maximum headroom. That's accomplished. That is what you want. Okay, so feedback adjustment. Oh, this is probably where you have to listen to it, because I like it to sound different than it looks with the feedback on, at least on the regular electric Mistress. Set the input to 200. All right, 0.2 volts peak to peak at 400 hertz. .2 volts is very low, peak to peak. My single generator might not have such little noise. At 400. Let's get it to 400 first. It's at 400 hertz, right? Yeah. Okay. Right about there. All right. Yeah. Okay. 0.2 volts peak to peak. That is very little. It's close. We've changed it so much that I want to recalibrate. Pretty close. Now I'm just curious, it's about 192 to 208. If I change the probe setting, what does it read? Jump way up, but is it a multiple of 10? What if I recalibrate it? Yeah. It's not really a multiple of 10. Maybe it's just having trouble reading it. Interesting. Okay, I'll put it back. That was just a kind of a personal experiment. See what happened there. Okay. Now, interestingly, that says it's not catching the frequency right. So we might have to do this at a different setting. It's kind of hard to believe that this signal generator I'm using, this WaveTech analog signal generator, is out of spec for doing this. All right. Let's try it like this then. Okay, at least that's catching the frequency right. And now it's going to want me to drop this so low. I won't even read it of it. Yeah, that's not going to work for me. 0.2 volts. I'm still above it at that setting. So let's see, would that be 2 volts at the 1x setting on the probe? Let's try it like that. Let's say I give it 2 volts at the 1x setting. Maybe that's more realistic, if I can get it there. But I'm not feeding the right signal to the device at that point. But it's more realistic to get it there. I have another meter that I could check the RMS output of it on. I don't know that I can do peak to peak on that though. I could try. So there's 2 volts. And if I drop it to 10x, it reaches 300. So it's like there's that probe maybe is not calibrated correctly. Let's get a really nice probe. Actually, I have like 8 other probes. $200 millivolts. Okay. Well. Give me 200. There we go. Very close to it. Can we work with that? And if I calibrate it again, it's going to give me something totally different. I think I'm just working at such a bad signal to noise ratio with that signal generator. I guess we're kind of close. I could take it up a little more. Okay. Yeah. I don't love this. Let's see what it wants me to do with it, because that's as close as I've gotten it so far. 0.2 volts. Set the color to maximum. Switch the filter matrix on. Check the output. Color to maximum. If it oscillates, adjust the feedback trim to stop it. Okay, here's the output. It's not oscillating, so we don't have to do that. We would see a lot of craziness if it was. Set the range to a point where output is at maximum. Okay, just feedback. Set feedback for about 0.7 volts, peak to peak. Okay. So range about 2/3 of the way up, and the audio output should be maximum. Yeah, because it goes back down there. So this is fun. I hope you guys are enjoying it. I'm just learning. Like, this isn't the how-to. Okay. All right, come on, show me the signal. And I'm looking for 700 millivolts, which is 0.7 volts. So I'm nowhere close to that. I'm still at 200 millivolts. Set feedback for an output of 0.7 volts peak to peak. There's no way. Yeah, maybe if I go to the 1x setting. Well, let's try it. Which one of these is feedback? Let's see. All the way over on the side. Oh, there it goes into oscillation right there. See it go crazy. Yeah, there's no way I'm getting 0.7 volts. I don't even think if I go to 1x I would get 0.7, but let's try. Yeah, I think that's the thing, is you just forget the 0.7. You're setting it to not go to feedback but get close to it. Okay. Final checks. Actually, I'm going to look at that again, because I kind of like it to go a little further away from oscillating. Like, I like it to be a little more subtle. The feedback is not something that I tend to set high on these. Okay. Alright, I'll set it by the book. So oscillating, bringing it back, not oscillating, and then a hair more. Yeah, okay, and that's still way hotter than it was before. Okay, final checks. Set the input, so putting the probe back on the input. Input to 0.5 volts, peak to peak at 3 kilohertz. We're going way up to 3 kilohertz. Should be about there. We're going to need a lot more volume. Closer to that. See, when the signal generator is up much higher, pushing some voltage, the scope picks it up better. I think that's just the signal to noise ratio on the signal generator. I got it as like military contract government surplus, and it might need a calibration. I think it's from the early 2000s. Might need a little tuning. It's okay, it's my backup. And it's definitely doing the job. Just not gloriously. Okay, we're close to 3 kilohertz, but we're not there. Let's go up. Okay, 3 kilohertz. Pretty close. All right. Gain through the wiper of the balancer trim pot 2 should go almost 2 times, so about 0.9 due to pre-emphasis, but the output should remain at 0.5 due to re-emphasis. Okay, easy enough. So we'll check that wiper and then we'll check the output. So we're at like, it's cycling between 475 to 525 or 540 maybe. Let's see. Oh, that's flanging, isn't it? That's pretty close. It's a little low compared to what I was putting in. Now let's see what it says at the wiper. Trim pot 2. Whoop! Jumpy, jumpy. .7 to 0.8. Okay, so it's a little bit low also. But it's all pretty close. It's, you know, it's doubling it and it's coming back down roughly. Look at pin 1 or 5 of the 4013 and switch to flange mode. Check for proper frequency modulation of the rate and range controls. Oh, this will look cool on the scope. Okay, check. Go to pin 1 or 5. Yeah. So we're back over here now. This is pin 1. Wait, I gotta look at the front panel for a minute. I forget which is speed. Range and rate is the bottom. Okay. So there's pin 1. Okay, now we go to flange mode. You're going to see these start expanding and contracting. And they do. Oh, the scope's trying to lock into them. Interesting. Like it's trying to counter it, but it can't. Look at that. It's flanging. That's what flanging looks like. At least the clock signal does. Okay, so is the rate and range. Okay, range goes down. Range goes up. Rate goes up. It should go faster. Oh yeah. Now the range should, I think it should change the width of those notches. Yeah, so they're narrower now with the range down, and as I rotate the range up, each notch should get wider, and it definitely does, independent speed. I'll slow this down and we'll do that again. So okay, that is range at maximum, and as I rotate it down, the width of those notches should become less. And indeed they do. So it's working right. Okay. Yeah, that's it. We're done. Nothing to do here. Here, let's get this camera back into it. Looking at the. Okay. Hey, well, I've got this off. There's Johan. Let's go. Don't forget the Tweed Deluxe sitting next to it. Oh, sorry. Tweed Basement, isn't it? Indeed. Okay. Okay. Let's get that locked back in. Okay, and nothing left to do but to put the cover back on and give it a listen. Some might say you should give it a listen before you put the cover back on. That's not bad advice. But I know I'm going back in here to test and possibly change some of those caps. Oh, let's turn the light back on. Hopefully that didn't just make a mess of the video. Intense settings. Too much for me. like those subtle settings. We'll take it up a little bit though. Well, very nice. I'm happy with it. Yeah, it does drop the volume just a hair, which is how it always was and how the good ones are. And if you run an overdrive of the right type, like say a Big Muff into that, it is very nice. It's not a tone suck, it is a tone enhance, and that it smooths out that overdrive, not because of the volume drop, but because of the loading, and it changes the frequency response and the dynamics and the whole feel of that overdrive and the sound entirely. And that volume drop is nothing but a side effect of an amazing thing happening with the interaction between the two of them that I would never want to change. Beautiful. Thanks for sticking around through that. I don't know why you did, but you must be even dorkier than I am to watch someone else do what I just did. So, please don't forget to dislike and unsubscribe. You do not want to see more of this garbage in your feed. Thank you so much. Have a wonderful evening.